Welcome back to Universal Things YouTube channel. Imagine finishing an exam, handing it in, the teacher grades it, and then somehow you're allowed to change your answers after the grading is done. That impossible idea is exactly what a real physics experiment hints at. Tonight, the delayed choice quantum eraser will challenge everything you believe about reality, time, and truth itself. Picture a tiny photon fired toward two slits. You expect it to pick one path and move on. But when no one watches, it behaves like a wave spreading, splitting, acting as if it took every possible route at once. It's as if the universe performs magic tricks the moment we look away. But the moment we place a detector to watch which slit it enters, the magic disappears. The wave collapses. The photon acts like a tiny, normal particle. It chooses one path. It behaves. It's as if the universe says, if you're watching, I'll follow your rules. Physicist John Wheeler wondered, what if we decide to observe only after the photon has already passed the slits? A choice made too late to influence anything, at least in our normal understanding of time. But quantum physics is not interested in our understanding. This idea led to the delayed choice quantum eraser. In this experiment, each photon is paired with an entangled twin. One photon hits a detector quickly. Its twin takes a longer route where scientists can choose to preserve its path information or erase it completely. If the twin's path information is kept, the first photon behaves like a particle, no wave interference at all. But if the information is erased, the first photon suddenly behaves like a wave. Even though it reached the detector long before that choice was made, reality reacts after the fact. It's like the photon's past depends on a decision made in its future. Not because time reverses, but because quantum events don't lock into a single story until information becomes final. The universe seems to wait, holding the past in a flexible, unfinished state. The real key is information. If the path is knowable, even if no one actually checks, it behaves like a particle. If the path becomes unknowable, the wave pattern returns. Reality doesn't care about physical action, it cares about what can be known. Yet nothing travels backward in time, no messages are sent, no paradoxes form. Instead, quantum entanglement creates connections deeper than space and time. The universe doesn't operate on our timeline, it creates its own. It's as if quantum particles float in a realm where past, present, and future blur together. Possibilities overlap until observation freezes one reality. The delayed choice shows that the universe isn't building time step by step, it's arranging everything in one connected fabric. Scientists call this non-locality. The two photons act as if they share a single fate, even when separated by distance and time. Changing what we can know about one instantly shapes the story of the other. Not through force, but through information. This experiment suggests the universe doesn't store a fixed history waiting for us to discover it. Instead, history becomes solid only when measurements are made. Reality doesn't simply exist, it forms through interaction. This is why the experiment is unsettling. It suggests there is no absolute reality behind the scenes. Instead, the act of observing finalizes one version of events from a cloud of possibilities. The universe waits for us to decide what can and cannot be known. Bohr once said, "No phenomenon is a real phenomenon until it is observed." The quantum eraser pushes this further, showing even the past is negotiable until the present forces a choice. Reality does not just react to observation, it depends on it. What scientists erase is not the photon itself, but the potential knowledge of its path. Erasing that information removes the universe's ability to label the particle's identity. So the wave returns, as if the particle had always behaved that way. Here's the twist that breaks logic. The interference pattern only appears when scientists later sort the data based on whether the path information was erased. The photons already arrived earlier, but the final pattern forms only after the future choice is applied. This forces a new question. Is reality choosing its behavior in advance, or is it waiting for us to decide what can be known? The delayed choice experiment points toward the latter. Reality is not fixed. It's responsive, flexible, and deeply intertwined with information. Some interpretations say multiple histories exist until one becomes consistent. Others say entanglement creates a single unified story across time. But all interpretations agree, the universe behaves nothing like the mechanical world we think we live in. This experiment doesn't prove thoughts shape matter or that we're in a simulation. But it does reveal that reality is profoundly connected to information. The universe behaves less like a cold machine and more like a system that responds to knowledge itself. So the delayed choice quantum eraser isn't just a physics test, it's a challenge to the way we understand existence. It suggests reality is not a fixed stage, but a story shaped by what can be known. And it leaves us with a haunting question: if the universe rewrites its past, what else might be possible?